Today we're going to be looking at fossil fuels. Now, fossil fuels are a natural resource. A natural resource is things that we get in nature. For example, water is a natural resource. Rocks and minerals are natural resources. And fossil fuels are going to be our natural resources. Now, there are some resources that are renewable and some that are non-renewable. So renewable means that they're easily replaceable. And it still may take years to replace them, but they can be easily replaced. For example, wood is also a natural resource. Wood can be replaced. It may take 20, 30 years for a tree to fully develop and grow before it can be used again as a natural resource. That's one of the reasons they have tree farms. But it is still a renewable resource, easily replaceable. Considered fossil fuels. Fossil fuels are not they're a resource, but they're not easily replaceable. And we'll see how fossil fuels take more than just a few years to develop. Fossil fuels are energy resources that are formed from fossils. And remember, fossils, when we think about them, we think first about the dinosaurs, but they are also any previously living thing can be a fossil. Your fossils are typically found in sedimentary rock, and we'll talk more about that in a second. Fossil fuels include coal, natural gas, and petroleum. Now, when we first think about petroleum, we think about petroleum jelly, such as Vaseline. Petroleum is different form in this context that we're talking about as a fossil fuel. So petroleum jelly is a liquid mixture of hydrocarbons that can be refined into gas products, which means we're extracting this material from the earth, we're refining it, and then we're using it in our cars. To power our cars is our primary reason we use petroleum gas in the United States. Now, think about this refining process. Well, in that refining process, some things are added, some things are taken away before it's used for the purpose that we have it. Think of it somewhat like milk. And I know before I say this that some people drink milk straight from the cow. You can do that. In the U.S., that's typically not how we do it. In the U.S., the milk goes through a refining process. So after it is taken from the cow, it is refined in a facility and packaged as milk that we buy now at the grocery store. So it's a mass production. Natural gas is a flammable gas composed of hydrocarbons that are used for energy, primarily heating homes, is what we use it for in the U.S. With the natural gas is actually colorless and odorless. And you're thinking, it's colorless and odorless, but I've seen a burner on a stove, and I see the blue color, and the tips are yellow or orange sometimes. True, but remember back to what we're talking about petroleum refining things. So natural gas, there's actually a process of adding chemicals to it, because you want to, if there's a natural gas leak, which is harmful, you want to be able to smell that and know what that is and what is happening. So they add to it, and it gives like this rotten egg type of smell if there's a leak, and that's actually for your safety. And you see the color because it's burning. So if it is burning, it's going to have some color with it as well. Petroleum / natural gas, they are both extracted materials, and you have to know the difference. Extracting, EX, I mean you're taking something out. For example, if you exit a room, which is EXIT, then you're going out of the room. Something's being taken out, and that something is you. So know that this is an extracted material. Now, petroleum and natural gas, being extracted materials, are actually formed from marine organisms. So these are organisms in the water, and they've most likely accumulated at the bottom. So what happens is they are buried and compressed into oil and natural gas. So here we have the animals have well, they're alive and kicking right now, but they've passed, okay? And then you get this buildup of the plant and animals that used to be there long ago, and sand and silt is now there. And then you have this, again, buildup. They drill through the sand, the silt, and the rock to reach the natural gas. And I want you to consider when we have oil and natural gas, we talked about sedimentary rock. And look at the word compressed. So remember, sedimentary rock is cemented and compacted. So when we looked at the word compressed, that's still cemented or compacted. So let's take a real quick look at a little recap video for you guys to watch on YouTube. And hopefully this should work out, for everybody.
What drives our cars, buses and planes? Powers our electricity and allows us to cook our food and heat our water. Most of today's energy needs are met by fossil fuels like coal, oil and gas. These unique, high-energy fuels are non-renewable resources that took millions of years to form. About 2 billion years ago, marine organisms like algae and microscopic animals and plants died and settled on the ocean floor. Beneath other sediments in the ocean, and in the absence of oxygen, these fossils changed into a substance called kerogen. Under heat and pressure, kerogen gradually changes into oil or gas. The whole process usually takes at least 1 million years. At the molecular level, oil and gas are hydrocarbons made up of hydrogen and carbon atoms. The constant pressure and movement of the Earth's crust squeezes oil and gas through the pores or spaces within rocks. Some oil and gas reaches the Earth's surface and seeps out naturally into land or water. Often it is trapped beneath the surface by impermeable layers or rock structures, like faults and folds. Within the crust, oil or gas deposits build up and form reservoirs. Reservoirs are like vast sponges filled with oil and gas. They can be as large as a city. To find oil and gas deposits, geologists use a number of different survey techniques, including seismic surveys, gravitational surveys, and geological mapping. Seismic surveys use reflected sound waves to produce a 3D view of the Earth's interior. New technologies, such as four-dimensional projections and sophisticated graphic renderings of rock structures, are improving the way we find conventional oil and gas deposits. Energy resources that are currently difficult or expensive to extract are called unconventional oil and gas. In a world with limited energy resources, people are looking at more efficient ways of tapping into unconventional oil and gas, or at alternative and renewable sources of energy from biofuels or the sun. What do you think will be the energy sources of the future?
I hope you enjoyed the video. We're going to move on just a little bit, still on the topic, but this is a more realistic view than what we saw previously in about 2 slides ago. So remember, this is 300 to 400 million years ago, this is 50 to 100 million years ago, and this is today. So after, I don't want to say the ocean has dried up because that's technically not exactly what's happening here, but you have these different layers, and they're very distinct layers, just like on sedimentary rock, very distinct layers of what is happening. And you take these old, I cannot remember, I'm sorry right now what they're called, I went blank. Anyway, you drill down, they have to get through that permeable rock layer, which means the liquids aren't getting through there, to find the oil that's trapped right along in this layer. Now right here is the gas. So here's our petroleum oil and here's our natural gas. And if you remember density at all, you remember that gas is generally lighter than liquid. So this is what it is. Think about it. We have talked, going back to where we have said that this is a natural resource, oil and gas, but it is not a renewable resource, which means it's not going to be renewed in your lifetime. Look at the millions of years it has taken. 300 to 400 million years, again, 50 to 100, and now today. So hundreds of millions of years to get to this trapped oil and gas before it is turned into fossil fuels. In your lifetime, we are not going to be able to renew the amount of oil that we are using. Now we're moving on to coal. So this is another one. So petroleum and gas, natural gas, go together. They're extracted. When it comes to coal, you mine for coal. And coal is, again, sedimentary rock. If it is a fossil fuel, it is related to sedimentary rock. So this forms from the remains of plants that accumulate at the bottom of swamps. So now you have moved from the accumulation of, I don't want to say living organisms, give me a second, from animals to now looking at the accumulation of plants. Okay? Sorry for that. So in the sedimentary rock, over millions of years, they become compressed into oil, into coal, and is burned to produce energy. Again, 300 million years ago, 100 million years ago, and now you can mine down for the coal. As useful as fossil fuels are to our survival as humans, they're also very harmful to the atmosphere. So it produces a lot of carbon dioxide. We also refer to carbon dioxide as CO2. And CO2 is a greenhouse gas, which we'll look at in a second. And greenhouse gases trap heat within the atmosphere and can potentially cause global warming. And we will get more into global warming as we go. But before we hit global warming, we have to stop and really understand what the greenhouse effect is. So what basically is happening with the greenhouse effect is you see the sun, this earth, this is the sun, sunlight that hits the earth is reflected and sun becomes heat. And when we get into weather, we'll really understand how all of the sun's rays do not get directly to the ground, the different paths that they take. Carbon dioxide and other gases in the atmosphere trap heat, keeping the earth warm. Being warm is a good thing, and being extra warm is not. So think about being underneath a blanket and covers at night, and the blanket is there to insulate the heat that your body has already given off. Okay? So when you use a blanket, use it because it's not exactly the blanket per se that provides the warmth. It's the fact that the blanket traps your own body heat. And that's why we use blankets primarily in the winter to do that, or whenever you're cold. It's a trapping of your own body heat. Also, think of a greenhouse. When you think of a greenhouse, think about using greenhouses. Actually, let me get a picture. Stopping for a moment, this is an example of greenhouses. So hopefully either, in person or sometime on television, you've most likely seen a greenhouse before. So for those who have not or cannot remember what it looks like, these are some examples. The most common one is this one and this one. They're normally built from glass because the glass traps the heat. So when you think about the greenhouse effect, you have the sun goes into the greenhouse, and these greenhouses traps the heat from the sun. The radial heat from the sun is trapped inside these greenhouses. So it keeps these greenhouses warmer. So even if in the summer, even in the winter, if it's cold, you will not have complete exposure. These greenhouses will be there to give the heat that the plants still need in order to grow. And there's more about greenhouses you'll learn later. I want you to think, before we move on, about the greenhouse effect again. So we've looked at it from using it as a blanket for example, and the blanket's helping you keep your heat in, your body heat, and keeps you warmer. We've also looked at what an actual greenhouse looks like. So how does the greenhouse effect come into play? How's the greenhouse effect come into play in our real lives? An example I always give my students is, think about when you're driving around in the summertime. You're driving around in the summertime, you're going to go run an errand or do something. You leave the car. What is one of the things you do that is different from what you would do in the wintertime? And I'm going to pause for a second. So the question was, when you exit the car in the summertime, what do you do differently than when you exit the car in the wintertime? And most likely your answer was, well, in the summertime, when I go to leave the car, I roll down the window. Or your parents roll down the windows. But in the wintertime, we don't roll down the windows. Why do you think that is? And that is an example there of the greenhouse effect in real life. As we spoke about, fossil fuels are non-renewable. They are a natural resource, but they are a non-renewable resource because over time, in a lifetime, those things cannot be renewed. At some point, they're considering, well, we know that we're going to run out of fossil fuels. At the amount at which we're using it, we're going to run out. So humans have to figure out a different way, different methods of using energy. And that'll be in our next lesson. But let's finish this one up. We're going to continue with natural resources. So we've looked at our fossil fuels, and we actually have one more fossil fuel to look at. But our primary fossil fuels we looked at were natural gas and oil, which are drilled for. And then we also have coal, and you mine for coal. Okay, that's how it's extracted. And now we're going to look at nuclear fission. Uranium and plutonium are natural resources. Okay, stop. Now, nuclear fission are your heavy metals, including uranium, plutonium, and they're split apart in a process to release energy. So these are nuclear, if you ever heard of especially like nuclear disasters or whatnot, it comes majority from something that's happened during that extraction process. So nuclear fission does not produce carbon dioxide, so it's a good thing in that respect. But like we said, when disasters strike, it's normally in nuclear energy, it involves some kind of meltdown that is happening, and actually we'll have that as another assignment for you to look at. If you get the opportunity, please look at the video on YouTube. However, in order to make sure I keep this one short, I'm going to go ahead and move on. Another natural resource is peat, okay, P-E-A-T. Peat is accumulation of partially decayed vegetation. So that's partially dead plants is what it breaks down to when you look at partially decayed vegetation. This forms when plant materials cannot fully decay because they're exposed to some type of acid or no oxygen conditions. Now, peat is harvested. So remember our methods of extraction. Peat is harvested. Now, peat is sometimes called the forgotten fossil fuel. Okay. Because they want to lump it with coal, because just if peat is able to continue to form, then it's eventually going to become coal. However, it is not coal yet, so therefore it's what we call a product of fossil fuels. It is not itself fossil fuels. Now, it is harvested and used to add more nutrients to the soil, so almost like a fertilizer. So I want to do a quick recap. We're reaching a 20-minute mark. Remember that coal and natural gas are drilled for. Okay, those are your top fossil fuels used for energy purposes. Coal is another energy source, and coal is mined for. And then you have peat, and peat is harvested. So you're going to have to know how those items are extracted, and you're going to have to know the pros and cons, which is going to take a little bit more research on your end. Okay, that's going to wrap it up. Go to Google Classroom for your assignment.